What's up, everybody? This is page 374. We're continuing our journey on exploring the tangent to a circle theorem. What we did on page 373, if you haven't watched it, go back and watch the video, is see that there's this relationship, like a 90-degree angle relationship that pops up. And in today's video, we're going to prove it, or we're going to use some methods of proof. So you only need like a highlighter and a pencil, maybe a couple of highlighters, because we're going to annotate. We're not actually going to solve anything. We're just going to read through some information, talk about how you process information, and then be ready to solve it. And at the bottom of this page is the actual theorem itself, tangent to a circle theorem. So feel free to pause the video at any time to create your own note card. A line drawn tangent to a circle is perpendicular to the radius of the circle drawn to the point of tangency. Essentially, that my tangent line right here, as you look at the radius, OP, the angle that's created is 90 degrees. And so that is what we're going to be proving, or looking at a form of proof for that today. Highlighters, something to write with? Let's get going. A proof of this relationship is completed by something called a contradiction. Now, a contradiction, right? A proof of contradiction begins with an assumption that is the opposite of what you would like to prove. Using the assumption and its implications, you arrive at a contradiction, and when this happens, the proof is complete. Now, honestly, that's a lot of math language for something you do all the time already. When you talk to a friend, your parents, someone else, and you try to say like, oh, so I should just, eat 500 pounds of chocolate and that'd be fine. Clearly, that's wrong. Like, you will die. So when you have that mentality in your proof, oh, so I should just drive my car at 300 miles an hour? No. When they say, no, that's not what you should do, you say, contradiction. I mean, in the back of your mind, right? You don't have to specifically name it, but in mathematics, we do. Oh, so 2 plus 3 is 1,000,000? That's a contradiction. And when you have that tone in mathematics, then logically, it is a logical argument, by the way, you are able to assume the opposite or conclude that the opposite of what you're saying is true. No, 2 plus 3 is not 1,000,000. No, when you eat a lot of candy, you do not have a healthy lifestyle. No, when you drive your car faster than the speed limit, you are not going to live for much longer, right? If you're going, something is going to be bad. So that proof by contradiction is a major concept that you already do, and geometry loves to use it, frankly. Well, let's see what it looks like here in a mathematical sense. But really, honestly, as you're reading with me and we're highlighting together, you'll catch the tone in my voice. Where does the proof by contradiction happen? Where does the, oh, really? That's what you think? Where's that happening at? Worked example. Line segment CA is a radius of circle, let me read this on the page, is a radius of circle A. And point A is the point at which, the radius intersects the tangent line. So highlight time, let's bring in some highlight color here and put green highlight for segment CA. Annotate, have some highlighters. Annotate means to process the information that we're given. Point A is the point at which the radius intersects the tangent line. So I might even try to add some extra layers of color. Point A, right there. Okay. Now we're going to know something, but we're going to make a guess about what's actually happening here. Let's assume the tangent line is not perpendicular. So we're saying we don't know if this is a 90-degree angle. In fact, we're going to say it's not. Oh, really? So let's just say the tangent line is not perpendicular. Now what are you going to do? Here's what we're going to do. Okay. Move this up here. Move this over here. If the tangent line is not perpendicular to the radius right here, if this is not an actual 90-degree angle, by the way, perpendicular, 90 degrees. Okay. Then let's find another point that is. Let's call that point, this is what you do, right? You're saying in your argument of, oh, so what you're saying is, well, then you are actually calling attention to something else at the same time. So therefore, point B should be the point that is on the tangent line and is perpendicular, right? The radius, or this line, it might not be a radius, but this line right here, we're going to say, okay, fine. This is step 2. This is step 1. No, this is the setup. This is the given. We're going to say, okay, fine. Pick point B. Something has to be 90 degrees. If it's not CA right here, if this isn't a 90-degree angle, somewhere else there is. Consider a right triangle, right? Hey, there we go. We've got a right triangle now. Consider a right triangle. Did you notice? I should highlight in orange. Did you notice that there's a right triangle that's created? I mean, if it's a line and another line and then a third line, then all 3 of those lines make a triangle. And because there's a right angle at this other point, oh yeah, really, like A's not, so B must be a right angle. All right, fine. You said it. B is a right angle. That means that CB is shorter than CA. Because the hypotenuse is always across from the right angle, so this is the hypotenuse. That makes this the Okay, that makes CA the hypotenuse, so it's going to be the biggest side. So however big this circle is, CA, that line segment, will be longer than CB. Okay, cool. Wait. Zoom in and enhance. Okay, look right here. We're supposed to be on the line. We're supposed to be drawing a line up to B. But just the way that we drew it, there's no way that as we've drawn C all the way down, I hope my mouse is being picked up by the capture, all the way down here to B, right, as this one right here, that line, this whole line right here is actually longer than CA. It's just not possible. The way that we drew it, right, we're saying that this has to be the hypotenuse. We're saying CA has to be the hypotenuse because it's across from the right angle. And yet the only way that we could draw this shape is if we draw C to D. It's a radius. It's going to be the same as CA and a little bit longer. This little bit right here that goes from the circle to that gap across to the tangent line, that little bit makes CB actually bigger than CA. That's the contradiction. Oh, really? So then if we don't have a 90-degree angle right here, then that must mean there's a 90-degree angle somewhere else. And then that means that CB is actually the only way that we could create a 90-degree angle. So that means CA should be bigger than CB. But look right here. I can just get my measuring device. I don't have my measuring device. I'll use this. I can just measure right here and tell you that's long. Okay, sorry. I'll drop the whole act. The point is CB is actually supposed to be bigger than CA. So we have a lack of conclusion. There's something missing. Therefore, this is impossible. The radius of the circle is shorter than this radius plus the little bit that it takes to get out to B on the tangent line. Therefore, the assumption is incorrect. No. You can't say that. You cannot say the tangent line is not perpendicular. This is incorrect. The tangent line is perpendicular. That's the whole point. By a proof by contradiction, we're going to assume something is false. We're going to pursue that false argument until finally we say, no, it doesn't work that way. It's broken. You have flawed logic. Ooh, bust that one out when someone tries to argue. You have flawed logic. Tangent to a circle theorem. Put it on a note card. Thank you for watching this video. We're going to practice this. We're going to use the 90-degree relationship when we talk about page 375. See you in the next video.